Primeira sessão plenária, alterações climáticas e o futuro. Segundo o relatório externo, caso nada seja feito, os custos e riscos gerais associados ao aquecimento global corresponderão a uma perda de cerca de 5% do PIB mundial por ano. Por seu lado, os custos associados às ações indiretas de redução de emissão de gases com efeito de estufa corresponderão a cerca de 1% do PIB global por ano. Peço, pois, a vossa atenção para o moderador desta sessão, Jorge Moreira da Silva, consultor do Sr. Presidente da República e da Comissão Europeia. Passo, pois, a palavra ao moderador desta sessão, Jorge Moreira da Silva, para conduzir alterações climáticas e o futuro.
Muito bom dia, vamos iniciar a nossa sessão. Ainda nos falta na mesa o professor Carlos Zorrinho, mas não tenho indicação de que se deva esperar, portanto vamos iniciar este painel. Este que é o primeiro painel deste congresso, um painel que procura analisar quer as questões científicas, quer as políticas públicas e as opções tecnológicas para enfrentarmos este desafio das alterações climáticas. Depois de alguns anos em que se assistiu a algum entorpecimento neste tema, em particular por ausência de diálogo entre as partes, seja entre cientistas e políticos, seja entre políticos e empresas, seja entre empresários e cientistas, hoje estamos num novo patamar de diálogo entre os diversos setores e eu recordaria muito brevemente factos dos últimos anos que demonstram que estamos num momento extraordinário para enfrentarmos este tema. Desde logo porque no plano científico o papel do painel intergovernamental para as alterações climáticas, com os sucessivos relatórios de progresso, tem demonstrado não apenas que estamos numa caminhada inexorável para a mudança climática, mas também que os sinais da mudança climática que aqui hoje já assistimos se podem atribuir ao homem. Por outro lado, surgiram os primeiros estudos, análise económica, custo-benefício das políticas para as alterações climáticas, como foi o caso do relatório Stern. Em terceiro lugar, os níveis de sensibilização do público relativamente ao tema atingiram um novo limiar. Isto é, depois de, durante muitos anos, este ser um tema dos peritos, dos cientistas, de alguns especialistas, com o livro e o filme de Al Gore e com a atribuição do Nobel da Paz e com o papel do IPCC, este é um tema que chegou aos cidadãos. Por outro lado, hoje vivemos em plena economia do carbono. O custo deste copo, junto do consumidor, internaliza o custo das emissões de CO2 e, por isso, aqueles que são capazes de produzir este copo com menos emissões de CO2 vencem. Aqueles que não são capazes de o fazer, nesta economia, já perdem. O comércio de emissões europeu tem tido um papel extraordinário neste sentido, juntando hoje já quase 15 mil instalações e, desde 2005, mas em particular desde 2008, assiste-se a um fortíssimo decréscimo das emissões impostas por este regime de comércio de emissões, basicamente procurando que as reduções se façam onde é mais barato e dessa forma se baixe o custo de cumprimento das metas de Kyoto. Ora, neste momento, decorridos estes anos longuíssimos de negociação e de entrada em vigor do Protocolo de Kyoto, neste momento a União Europeia tem em curso um debate sobre as novas políticas. Espera-se que até dezembro a presidência francesa possa chegar a acordo no Conselho e com a Comissão e com o Parlamento e iniciar-se-á em dezembro, dentro de 15 dias, uma nova ronda sobre o regime climático pós-2012. E é neste contexto que este painel, que esta discussão se irá travar. Basicamente, julgo que é importante nesta discussão ver respondidas 3 ou 4 questões. Em primeiro lugar, o que é que o regime climático pós-2012 deve impor, seja ao nível de metas de redução das emissões, seja ao nível de compromissos para a adaptação, em particular, ajudando os países com maior vulnerabilidade, estou a pensar nos países em vias de desenvolvimento, quer em termos de transferência de tecnologia. Por outro lado, é necessário saber o que é que as políticas públicas nos Estados e também a nível internacional são capazes de fazer para colocar um preço adequado ao CO2, um preço que esteja em linha com as metas internacionais de estabilização da concentração de emissões de gases com efeito de estufa, mas também o que é que as políticas públicas devem fazer para remover as barreiras hoje ainda existentes à plena integração das novas tecnologias, de tecnologias mais limpas. Finalmente, é necessário saber o que é que as políticas públicas são capazes de fazer para reorientar os comportamentos dos cidadãos. Esta é uma matéria que não se pode centrar apenas na tecnologia. As alterações climáticas são uma matéria de responsabilidade e de ética e, neste caso, é importante promover uma mudança de comportamentos dos cidadãos. Finalmente, a todos nós, às empresas e aos cidadãos, importa saber de que forma é que queremos cumprir as metas de forma custo-eficiente. Ao contrário do que muitos têm procurado fazer crer, o que está em causa não é cumprir ou não cumprir o Protocolo de Kyoto. O que está em causa é saber a que preço, com que custo, com que oportunidades queremos cumprir as metas de redução das emissões. E estas são questões que penso que podem ser debatidas neste painel. Eu passo a apresentar os oradores. O nosso keynote speaker é o professor Chris Hope, da Universidade de Cambridge, que é um influente cientista no âmbito do painel intergovernamental para as alterações climáticas, que recentemente publicou o 4º relatório de progresso. O professor Chris Hope é um lead author do IPCC. Depois teremos a intervenção, seguindo esta ordem, do Bill Harnod, Chief Research Officer da Canary, uma associação, uma organização canadiana de desenvolvimento das comunicações e da internet. Em seguida, teremos uma intervenção do professor Carlos Zorrinho, subejamente conhecido, é o Coordenador Nacional da Estratégia de Lisboa e do Plano Tecnológico. Finalmente, teremos uma intervenção de Martin Fleming, que é vice-presidente da IBM, com a área da Corporate Strategy. Eu dou a palavra ao professor Chris Hope.
I have some slides which I hope will appear at this point. Thank you. First of all, can I say thank you to the President of the 18th Congress for inviting me to help you start the work of the Congress by considering the science and economics of climate change. What I'm going to do in the half an hour or so I have available to me is to deal with three topics. Could I have the next slide, please? Thank you. First of all, to think about the science. What are the reasons for concern about climate change? Then to move on to the combination of science and economics. How do the impacts of climate change affect us? And then to move through to think about economics. How much should emitters of greenhouse gases pay for the impacts that their pollution causes? Quite a lot to deal with in half an hour, so let's move on. We've heard from the President of the Republic just a few minutes ago just how serious Portugal thinks that climate change is as an issue. And we have other statements from other leaders of scientific communities and political communities around the world. Lord May is president of the UK's oldest scientific society, and he said that climate change can be likened in its destructive scale to the effects of using weapons of mass destruction, a very serious issue. And just 1 week ago, less than 1 week ago, President-elect of the United States, Barack Obama, in his acceptance speech, in just 13 words, put climate change there up in the very top group of concerns for himself, his presidency, and the world. The fact that he is inheriting 2 wars, a planet in peril, and the worst financial crisis in a century. So what lies behind these statements? The science of climate change and the greenhouse effect is actually very well known. It's based not on modern science, it's based on 19th century physics. That's when it was first identified as an effect. And all that's happening is that as the sun heats the earth, the rays of the sun come and hit the earth, and some are reflected back out as longer wavelength radiation. And the greenhouse effect gases stop some of those long wavelength radiation rays getting back out into space and reflect them back down to the earth again. And that just means that in order for the earth to be in balance with the heat coming in and the heat going out, as it must be in the long run, the earth has to be at a higher temperature for those two things to balance. There's no dispute about the greenhouse effect. It's verified, for instance, by data from the planets, Mars, Venus, Mercury, and the Earth. Mercury is the closest planet to the Sun, as we see on the top, and yet its temperature at 179 degrees centigrade is lower than that of Venus, which is further away from the Sun, whose temperature is 420 degrees centigrade. And the reason for this is that Venus has an atmosphere almost entirely composed of greenhouse gases. We also know, from calculations done many years ago, that the Earth's surface would be about 33 degrees centigrade cooler and frozen over completely if we did not have a greenhouse effect in the atmosphere. So why are we worried about this? Well, that is the natural greenhouse effect. That's the effect that's been there for millennia and is not what we're concerned about when we talk about man-made greenhouse effect. If we look back over the last 500,000 years, we see that the main greenhouse gas that we're concerned about, carbon dioxide, the concentration of that in the atmosphere has fluctuated within fairly well-defined bounds. It's been through a low down to about 180 parts per million on the blue line, and up to a high of about 280 parts per million. And for the last 500,000 years, the concentration of this main greenhouse gas has been between those two limits. When it's been towards the top end of the range at 280 parts per million, we've had a climate very much like today's and the 20th centuries. When it's been at the low part, at 180 parts per million, the climate has been an ice age, with ice sheets covering northern Europe down as far as the north of France and the Netherlands, 2 kilometers thick of ice. So the difference between a carbon dioxide concentration of 180 parts per million and 280 parts per million is the difference between an ice age and the rather pleasant climate that we've had in the 20th century. Now, the Intergovernmental Panel on Climate Change has looked at what we might expect to see happen to the concentrations of climate change over the next century. And you see various projections there for what might happen to the concentration of this gas if we don't make attempts to deal with the problem. The differences are because there are different assumptions about how the world will grow, how it will organise itself, what the population will be, and so forth. But you can see that the vast majority of these scenarios of the IPCC have an increasing concentration of carbon dioxide from 380 parts per million, which is roughly where it is today, up to 5, 6, 7, maybe even 8 or 900 parts per million. And if we superimpose that on the previous slide, which showed the concentration over the last 500,000 years or so, essentially we have an instantaneous rise far outside the range that the world has been used to coping with in the past. None of this is controversial, by the way. No climate change skeptic would disagree with those values for carbon dioxide concentrations. What the skeptics have to say, really, is, okay, I know that the difference between 180 parts per million and 280 parts per million is the difference between an ice age and today's pleasant climate, but I'm not worried about it going up to 500, 700, 800, 900 parts per million. I really don't think that's going to cause us a problem. Well, that doesn't seem like a very prudent way of viewing the issue to me. And indeed, in the IPCC, they don't take that view. The leading scientists around the world have again looked at what would happen if the concentrations of greenhouse gases increase. And here are some of the scenarios that I showed earlier, now not showing concentrations of greenhouse gases, but showing what's likely to happen to the mean temperature around the world. And you can see the 20th century in black, the historical record. Temperature has risen by nearly 1 degree centigrade over the last century or so. And you can see the projections into the future of what will happen if we continue to allow the greenhouse gases to increase as those scenarios define. And the scenario that we're closest to being on now at the moment is probably the red one, the A2 scenario, or maybe even slightly above that. And you can see that the red scenario would predict that the temperature will increase by maybe 3 or so degrees above today's level, 4 degrees above pre-industrial levels. And if you look on the right-hand side, you will see that there is a great deal of uncertainty about that projection. Whenever we deal with the science and economics of climate change, if we're going to be honest, we have to admit that there is uncertainty about the projections. But the uncertainty, unfortunately, is not comforting, because the uncertainty could mean, if you look at the A2 line on the right-hand side and the grey bands around that the temperature, well, our best guess is maybe it will rise by 3 degrees from today's level, but it could actually rise by 5 degrees from today's level by 2100, 6 degrees compared to pre-industrial levels. And our chairman mentioned the Stern Review of climate change that was carried out in the United Kingdom 2 years ago. And the Stern Review indeed looked at what the impacts might be if we were to have this kind of change in temperature. Now, along the top of the chart, you can see the change in temperature compared to pre-industrial levels. We are, at the moment, nearly 1 degree centigrade above pre-industrial levels. And you can see the kinds of impacts that we would expect to occur as the temperature goes up 1, 2, 3, 4, 5 degrees. And you can see that in green, there is possibly, for small amounts of climate change, some areas where there will be some benefits. High latitude regions with agriculture, maybe in Canada, maybe in Siberia, possibly some increased yields. But the vast majority of impacts, even for small amounts of climate change, and essentially all impacts for larger amounts of climate change, the 3, 4 and 5 degrees, will be negative. In the water sector, with glaciers disappearing, on which 1/6 of the world have their requirements for water, yields in agriculture in developing countries falling and maybe some areas being unable to support agriculture. ecosystems dying out, extreme weather events as the atmosphere has more energy in it because it's warmer, everything will become more intense, hurricanes, storms, heat waves. And at the bottom you can see the one that the Stern Review called risk of abrupt and major irreversible changes. The IPCC calls it large-scale discontinuities, very neutral language. What it actually means is climate catastrophes. Because there's some possibility, if the temperature rises by more than 2 or 3 degrees above pre-industrial levels, that we will have very major changes in the way that ice, for instance, is distributed around the Earth. The West Antarctic ice sheet, the Greenland ice sheet could possibly start to melt. And if they melt, then we're talking about sea level rises not of maybe 1 metre, which is the average that we might expect by the end of the century for a 3 or 4 degree centigrade rise. No, the sea level rise would be 6 or 7 metres if either of those ice sheets melted. Maybe up to 15 metres if both of them melted. A complete redrawing, essentially, of the maps of the world. So how can we take that kind of information? You'll notice that on the previous slide, the arrows didn't sort of come to a point and fall off a cliff and say, if we go beyond 2, everything will be awful. If we stay below 2, everything will be fine. What they say is that as we get higher and higher temperatures, it's more and more likely that we will face bigger and bigger risks. And we have to take that into account in any of the assessment that we do of the economics of climate change. And the tools that we use for doing that are models, integrated assessment models, which put together the science and the economics to work out the emissions of greenhouse gases, to work out what the temperature changes are likely to be, what the climate is going to be in different areas, what the physical impacts will be in terms of ecosystems or health or the economy, and then to put some valuation on that. And any of the integrated assessment models that are worth listening to recognize that there's a great deal of uncertainty in doing those calculations and calculate their answers with big ranges around them as the uncertainties continue through the modeling process. And the kinds of outputs that we get are shown in this slide. What are the impacts if we add together all the impacts in the different regions of the world, all the different types of impacts that we saw on the previous slide from the Stern Review, and project that forward over the next 100 years or so, and try and put some sort of valuation in terms of currency on those kinds of impacts, economic, non-economic, and catastrophic impacts together. And up the left-hand side of the chart, you can see that the values are there in billions of dollars. And that if we follow one of the scenarios that it looks as though we're on at the moment, the A2 scenario from the IPCC, our best guess is that by the end of the century, as the worst effects of climate change are being felt, that the impacts worldwide will be of the order of 10,000 billion US dollars, 10 trillion US dollars per year. And you can see the range of uncertainty around that, labelled 5% and 95%, to say that we don't know, of course, exactly what will happen because we don't know exactly what will happen to the temperature, and even if we did, we wouldn't know exactly what the valuation of the impacts would be. But the sort of range of numbers that we're talking about there, if we add them together over the whole time period from now until the end of the 22nd century, and discount them back to the present day using standard economic models to discount them back, you can see at the bottom of the slide, would say that the total global impacts of those next 200 years or so from climate change might be, our best guess, around 70 trillion US dollars, could be somewhere in the range of 10 to 200 trillion dollars. And to give you some sort of context for that, the total size of the world economy in the year 2000 is about 40 trillion US dollars. That's the total productivity of the whole economy of the world. So what we're talking about is impacts of climate change over the next 200 years being equivalent to perhaps 2 years' worth of total product from the world economy, and a big range around that. And this is something else that comes out of the modelling. Who is it who suffers these impacts? Well, here we can see, if we divide the world basically into the developed regions of the OECD, Annex 1 countries, and the rest of the world, the developing countries, over 95% of the impacts for the next century we would expect to be felt in developing poor parts of the world. Why? Why is it so low in the developed countries and so high in the developing countries? The first factor is that in developed countries like Portugal, the Netherlands and the UK, we're actually less vulnerable. We tend to be in fairly temperate parts of the world where the climate is in a reasonable range. We're not in the middle of Africa. We're not in the places where the climate is already at the extremes of being able to grow things or to live. We've seen as well that indeed there are possibly some positive impacts in developed countries for small amounts of climate change, agriculture in Canada, in Siberia. A big effect is that there is greater capacity in developed countries to adapt to climate change. We know that the Netherlands already is below sea level, and yet it isn't inundated because it can adapt to that. It has a sea dike around it in order to keep the sea out. And if the sea level were to rise by half a metre or a metre, it's undoubtedly true that the Netherlands would be able to adapt to that by building up the sea dikes. In the lowlands of Bangladesh, such adaptation is not possible. If the sea level were to rise half a metre or a metre there, we would be talking about millions, probably tens of millions of people being displaced and unable to carry on their lives. And the final point is that as poorer countries are indeed poorer, we would want to weight any impact in a developing country higher than an impact of the same dollar amount in a developed country. We would want to say, as we know, that a dollar's worth of impact to a poor person is a lot more severe than a dollar's worth of impact to a rich person. And all of those four effects are there in the modelling and lead to the developing countries having such a large share of the impacts. So if we can do those kind of calculations in the integrated assessment models to try and work out what the economic scale of the impacts might be, we can do the next stage. We can say how much extra impact is being caused if an emitter of greenhouse gas emits one more tonne of carbon dioxide or of methane or of nitrous oxide. But carbon dioxide is the main gas, and that's the one that I'm going to concentrate in the last few minutes here. And the Stern Review, when it went through these kind of calculations, did indeed come up with a figure for that. They calculated that each tonne of carbon dioxide emitted in the year 2001, which was the base for their analysis, caused about $85 worth of extra damage. And that this will be rising year on year as we get closer and closer to the time when the biggest effects are likely to occur, so that if we emit 1 tonne of greenhouse gas later on, then the impacts are rising at about 2 to 3% per year in real terms. And if we translate this through to today and put it into year 2008 dollars, that implies that the damage caused by a tonne of carbon dioxide emitted today is round about $120. But you remember I said there's a huge amount of uncertainty here, and you should only take seriously people who show you that uncertainty, so I'm going to do that. If we put into the integrated assessment models the numbers that were used by the Stern Review and calculate the range that we would see for possible impacts from an extra tonne of carbon dioxide, we can see that our best guess indeed is that it's about $120. But it could be as low as $30 if we're very lucky, or it could be as much as $360 for a tonne of CO2 if we're very unlucky. Now, most of us don't carry around in our heads what that implies if we were indeed to say that each tonne of carbon dioxide causes $120 worth of damage, and therefore we would charge an emitter of a tonne of carbon dioxide $120. What does that imply in terms of the changes of prices of things that we're really interested in? Well, you can see that it would add about $45 to the price of a barrel of crude oil when you take into account the emissions that are likely to occur from burning that barrel of crude oil. Typical price last week when I put this together, about $65 per barrel per tonne of crude oil. It would add about 20 euro cents to the price of a litre of petrol. Typical retail price in the EU about €1.40 per litre. It would add about 2 euro cents to the price of a kilowatt hour of gas, and typical retail price around Europe is about 5 euro cents per kilowatt hour at the moment. Electricity generated from coal would be about 7 euro cents per kilowatt hour more expensive. Electricity generated from gas about 3 euro cents per kilowatt hour more expensive, as gas it doesn't emit so many greenhouse gases as coal. A typical retail price at the moment about 12 euro cents per kilowatt hour. And it would add about 75 euros to the price of one passenger ticket from London to Lisbon return. And who knows what the typical retail price of that is. It depends on what day you go on the low-cost airlines website. But 75 euros is quite a significant addition to the cost of that. So you can see, if we were to take it seriously and take seriously the Stern Review numbers for the impacts from one more tonne of carbon dioxide being emitted, we would have really quite large changes in the price of our energy supplies and the things that we do with them. And I can hear you, as most people that I give this talk to, saying, gosh, you're really telling us that what we need is to make things that we rely on more expensive, just at this moment when we have a financial crisis, when we're struggling to pay for our houses, when we're struggling to meet our bills. And the answer is yes, this is exactly the time to make those things more expensive. Because if we do it in the right way, then it doesn't cause problems for the economy, it causes benefits to the economy. And the right way to do this kind of increase in price is to either use a carbon tax, which applies to every emitter of carbon dioxide and other greenhouse gases, or to use emission allowances, which anybody who wants to emit a tonne of greenhouse gas has to buy if they're going to make that emission, and make the people buy those permits, emission allowances, in an auction rather than giving them away free. And the reason for doing it in that way, either with a carbon tax or with auctioned emission permits, is because you would then get very large revenues from the taxes or the auctions. And if those are spent in the right way, on reducing other taxes, which we all find a burden at the moment, income taxes, VAT, national insurance contributions, taxes on corporations' profits. Then modelling work that's been done in Cambridge by Terry Barker shows that we will be able to reduce the costs of tackling climate change by about 2% of GDP. And as the Stern Review's estimates for the costs of tackling climate change are anywhere between 0.2% and 2.4% of GDP from the engineering measures that are required if we don't do this kind of revenue recycling, we can immediately see that if we do this revenue recycling and tackle the problem in the right way, then the economy could benefit by up to 1.8% of GDP, or possibly have a small cost, but most likely would end up having a benefit. Why would that occur? Well, if we just look at one of the member states of the EU, which I know most about, the UK, suppose we were to put on a climate change tax of $120 on every tonne of carbon dioxide. How much revenue would we get from that? Well, the revenue in the first year from carbon dioxide will be about 47 billion euros. If we then include the UK's share of international air travel and the damage being caused by that, that would bring in another 5 billion euros worth of revenue. If we were to bring in other greenhouse gases like methane and nitrous oxide, as we would indeed have to do in the medium term, that would then bring in about another 8 billion euros of revenue. So we would have a revenue of about 60 billion euros from a climate change tax or from auctioning emission permits. And if you look at the bottom of the slide, you'll see that the total tax revenue in the United Kingdom is about 600 billion euros. So we're talking of maybe 10% of the total tax revenue coming from these kind of climate change taxes or emission allowance auctions. This is a huge sum of money. This is not a stealth tax. This is not something that could be hidden away in the government's books. This is something that would require the government to reduce other taxes like income taxes or sales taxes to stimulate the economy and to grow faster than if we do nothing about climate change, quite apart from all the benefits that we get from incidentally tackling this problem and solving the climate change issue. And what is actually happening? Well, in the UK, anybody who wants to bid for a government contract does indeed have to use a shadow price of carbon in their bids that they're putting in. Every tonne of carbon dioxide that's emitted from a project has to now be costed. It has to be costed in a way that reflects the impacts that will be caused by that tonne of carbon dioxide. At the moment, the price that was used when it was set up in 2007 was £25, about 35 euros per tonne of CO2 for every tonne emitted. This is rising in real terms by 2% a year to reflect the fact that the emissions will get worse and the impacts will get worse as we go further and further into the future. And this number will be reviewed in full every 5 years. And my expectation is that it will go up rather than down when it's reviewed in order to take account of the full impacts of climate change. So I leave you with just some thoughts of the threats and the opportunities that we see when we look at the evidence on the science and economics of climate change. The first clear fact is that developing countries will feel the worst impacts of climate change. They are the most vulnerable. They are the ones who can do least about it. It's clear that we historically, in the developed countries, bear the biggest share of blame for the emissions of greenhouse gases, and therefore we have to take the lead in setting a carbon price, in dealing with the issue in an economically efficient way. What will the carbon price be? Well, I would encourage you to think what the opportunities could be for your business and any clients that you might have if the carbon price ends up being somewhere between 35 to 85 euros per tonne of carbon dioxide equivalent, rising at 2 to 3% a year. And because the revenue is being recycled properly, the cost of labour is falling because income taxes are going down. What are the benefits that you would have? What are the opportunities there in your business? How can ICT take advantage of this kind of changed business climate? And the reason for thinking that it will pan out in this way, that this is what will happen, is that if we want the rest of the world to take this issue seriously, we can't force them to do it. We can't force China and India and Brazil and developing countries to take account of this issue of climate change. We can only demonstrate to them that if we do take account of it properly and do it in an economically efficient way, then our economies will thrive, we will set the lead, and China and India and Brazil and the other developing countries in the medium term will want to join any regime that allows and helps their economies to thrive. But we have to be the ones who show that it can work. The models say it work. We need in Europe and in the US with an incoming administration to show that we have the courage to believe those models and to take these kind of actions ourselves. Thank you.
Muito obrigado. Eu vou dar a palavra ao Bill Arnold da Canary.
Thank you, Mr. Speaker, and I'd like to also express my congratulations to the organizers of this conference and this event for putting on such a wonderful opportunity here about the challenges of ICT and global warming. And I'm really pleased to see this large attendance here for a very, very important topic. I have a set of slides as well, which I hope that we can hear there. Okay. Now, Chris's talk was a very good segue into what I'm going to talk about, and that's the economic opportunities, specifically how ICT can help reduce the challenges of climate change, but also be a very significant business opportunity. And that's through broadband and internet. Just to re-emphasize what Chris is saying, we know the challenges Just one point, the latest data that came out indicates that we are tracking higher than even that A2 scenario. The threat to the climate is very real. And one thing I want to emphasize, small incremental changes are not going to be sufficient to address this problem. We need fundamental, real serious changes if we have any hope of slowing down the rate of growth of global warming. This is just a simple slide, I think really illustrates the challenge we face. The average CO2 per person in North America is about 26 tons of CO2. In Europe, it's a little bit less. And we have to get down to 2 tons per person by 2050. That's a huge reduction in our average CO2 emissions. And it's a daunting challenge we face. But I really think that ICT and broadband could really play a significant role in achieving a good percentage of that reduction and being a benefit to the economy, not a sackcloth and ashes stories, but really a major stimulus to our global economy. There was a recent report that came out called Smart 2020 and several others, The Inefficient Truth, that shows that the ICT industry is really a significant contributor now to CO2 emissions. The total estimated emissions of ICT and internet and broadband is greater than the aviation industry in total around the world, and that's about 2 or 3% of global emissions. But what is more significant is that the emissions from the information communication technologies is doubling about every 4 to 6 years. If this growth rate continues, ICT will be one of the major contributors to global warming, even beyond smelters and coal plants and so on and so forth. So this is clearly an unsustainable growth rate. We have to clean up our own house first. We cannot let ICT to continue to grow in this rate of emissions. Just to give you one small example from this report, one small computer server sitting in your office generates as much CO2 as a normally driven suburban utility vehicle at 50 miles per gallon. Now that, of course, is based on assumptions that the power for that server comes from a coal-driven plant and so forth. But it really puts in context the amount of CO2 that our industry produces from a simple device like that. And what is worse, the average utilization of many of our computer servers around the world is less than 6%, according to a recent report from McKinsey. So a lot of efficiencies and reductions in CO2 emissions can be gained by consolidating servers through virtualization and other techniques as well. Now, as Chris mentioned, governments are wrestling with many challenges to global warming, looking at different policy approaches. There's no question that economists argue carbon taxes is by and far the most effective and most efficient technique for pricing out externalities like CO2 emissions. But particularly in North America, this is a very difficult thing to sell. We just had an election in Canada where the party advocating a small tax was roundly defeated. And in the one jurisdiction where we have a tax in North America, it's very, very difficult. There's been protests, there's been riots, and so forth. So although it's the best solution, it's going to be very difficult to sell. The other approach, of course, is cap and trade, which you have here in Europe, and which now President-elect Obama has promised the United States. And that is not quite as efficient, but it will be effective. It will address the problem of the supply side of CO2, and it really will be sort of like a hidden tax. The other approaches are carbon offsets. This is what you see in the voluntary markets, where if you go to a website when you purchase an airline ticket, you can agree to pay a few dollars extra for the carbon emitted to your travel. And there's other things. Companies are going voluntarily, becoming carbon neutral and so forth. And so this is a fairly large market as well, but it needs to be regulated, but it is growing quite significantly. Also a growing trend is now many jurisdictions are looking to impose carbon neutrality by law. The province of British Columbia has done this in Canada, New Zealand has done this, Sweden is looking at it, and several states are doing this. And this is very popular with politicians because it does not mean imposing a tax on voters, and also does not mean increasing the cost of gasoline and electricity. But it can impose a significant restriction on the public sector and companies and those bidding on contracts from the government. So if you are a supplier to government or to any public sector organization, prepare for this, because it's a very attractive proposition to many politicians. In British Columbia, it's causing severe panic amongst their hospitals and universities because they have a year and a half to become carbon neutral. And if they don't, they must pay real money into carbon trusts and voluntary offset programs. And these costs can be quite significant, can be millions of dollars for for a single institution. So it's coming. This freight train is coming very quickly. Be prepared for it. We don't have to wait for Copenhagen. There is a number of approaches being talked about in the policy arena, and these are some of them out there. But we believe there's even a more effective approach beyond these ones, and that's to use ICT and the Internet. Another report that came out called Smart 2020 by an organization called Jesse, clearly indicated that ICTs have this contribution of 2 to 3%. That's a bad story, but ICTs and Internet can really have a much more significant role in helping us reduce CO2 in other sectors of society through indirect means. And that's using smart technologies in all sorts of fields, from smart homes, smart buildings, all these things talked about by IBM and Cisco and so forth. And this is where we can really have a significant impact. And this study is one of the more conservative ones. There's others that indicate that the impact of ICT in reducing CO2 emissions can be even much greater than this, as much as even 50%. In fact, one study in Japan indicates that ICT alone could help Japan reach 90% of its Kyoto targets. 90%. That's the impact that ICT might have. Now, of course, all these studies, I haven't put in a range of estimates or mean like Chris has, I should have, but even if it's only 50%, even if it's only 25%, that's still a very significant impact on reducing CO2 emissions. Now, this is another study that shows where the biggest impact will come from ICT. Many people talk about, video conferencing, telecommuting, teleworking, and so forth. And you see from that slide that really those will only have a marginal impact. Where the biggest impact will come is from virtualization. Virtualization of computers, of networks, and of products. So everything from books to movies, all sorts of physical instruments today, if we virtualize them, that will where we will gain the biggest impact in terms of CO2 reduction. Now, if you virtualize these things, you need then broadband networks. You need a very highly integrated, high-speed infrastructure throughout your country if you want to achieve these types of goals using ICT. And delivery of these products, and people who have virtual products now will be the big winners in this marketplace and also can earn carbon offsets through this type of activity as well. Now, one thing I want to talk about, you're going to hear a lot from various speakers and from various companies who are confusing energy efficiency, energy consumption, and sustainability with reducing greenhouse gases. These are all important issues, things like e-waste, for example. But these are small issues compared to reducing global warming. Global warming is the one biggest threat facing this planet and can be more devastating than a nuclear war and its total damage to this planet. This is the one thing we must focus on. And this is why talk about energy efficiency can be very confusing and can actually be leading us in the wrong direction. In the last energy crisis in 1973, the United States Congress passed a series of laws mandating the first minimum efficiency for automobiles, homes, and appliances. Everybody said, this is great. Now that we have minimum mileage on our cars, minimum insulation for the homes, this will reduce our dependence on foreign oil for the United States. Well, what happened was just the exact opposite. American dependence now on foreign oil has increased, and economists discovered that, in fact, energy consumption increased because of energy efficiency. This is referred to as the Jevons paradox, or the Kazum-Brooks postulate, or the rebound effect. What energy efficiency does is reduce the cost of a product or service. So the natural consumer response is, if your car is more energy efficient, is to drive it further or buy a bigger car. Or if your home is more energy efficient, you buy a bigger home. Same with appliances, you buy bigger appliances and so forth. So we have to be very careful about a lot of these claims and studies about energy efficiency and so forth and reduced energy consumption. We really must do a detailed inventory analysis and understand the problem we're trying to solve. Because sometimes some of these early, easy solutions may be leading us in the wrong direction. Now, as I argued, as Chris pointed out, is that there's significant economic opportunities in addressing the problem of global warming. This is not a totally bad news story. Countries and businesses that move first, the early adopters, the early movers, will be the big winners in the future zero-carbon economy. And I think ICT and the Internet has the biggest opportunity for creating wealth and creating new business opportunities. And so countries that are first to move with broadband networks and initiatives like that will be the big winners in this future economy. Just to give you an example of the size of this economy, Chris pointed out some of the numbers there, but the opportunities in terms of what's being traded from cap and trade and taxes and from the voluntary markets is that just in the low energy markets, about $500 billion by 2050, $100 billion in greenhouse gas emission credits by 2030, and $57 trillion in carbon disclosure activities and so on and so forth. This is big dollars. The numbers are staggering. And if you just apply even a small percentage of this, we could address all sorts of social problems from health care, from mortgage crisis, could pay for several Iraq wars, and could pay off the debts of millions of banks. This is a real serious money, and those who move first to take advantage of this will be the big winners. And guess who right now is winning this game? China. China last year earned $7.3 billion from Europe in the carbon trading markets. And that was spent on planting trees, building hydro dams, and so forth. That money could be spent here in this country, building broadband networks, solving social problems, and so on and so forth. But entrepreneurs in China have captured this type of business. So Portugal, I believe, could be a real leader in this area. Your government has made a commitment of generating 31% of your energy from renewable sources by 2020. You have projects like this, one of the world's first wave projects off the coast of northern Portugal. It's initiatives like this, I think, in combination with ICT and broadband, could really make Portugal a world leader in adapting to this new economy. We must move as quickly as possible from the old energy-intensive economy and use these new techniques and use ICT and broadband, especially to develop new industries and new services. Here's another study, again from the UK, that shows that consumers actually control or influence 60% of CO2 emissions, 35% directly through their transportation, their heating of their homes, and so forth, and 25% indirectly through the products and services they purchase. So if we can get consumers to reduce their CO2 footprint, we can have a major impact on global warming. So one thing we've been advocating, in addition to these other policies of cap and trade and taxes, is carbon rewards rather than carbon taxes. Carbon taxes are so difficult to sell, they penalize the customer, they don't see any direct benefit, and what we're suggesting is, why don't we reward the consumer for reducing their carbon footprint? And so there's a number of things being talked about. That could be delivering of virtual products, it could be delivering of free cell phone service if you use a bus, delivering of free advanced telepresence systems, and all sorts of things we can do with ICT, because ICT has such a small carbon footprint. We can reward consumers with ICT products and services in exchange for them reducing their carbon footprint. So the problem with carbon taxes, the money disappears to government, yes, and go to reducing our overall taxes, but there's no direct benefit or reward to the consumer. And we know the success of loyalty programs and so forth, and we think carbon rewards is another tool we can use to really help move forward in reducing our CO2 emissions. And one example of that is we have a project underway in Ottawa, and now several other cities have copied this, where we're providing free high-speed broadband, free fiber, free internet to the home, if the consumer agrees to pay a voluntary carbon tax. So we charge the consumer an extra 2 cents per kilowatt hour, and for that the consumer gets free fiber and free high-speed internet. And we encourage the consumer to reduce their carbon footprint by turning off their lights, turning down the thermostat, and so on and so forth. And so in total, the total bill for the customer, including energy, triple play, and internet, can be substantially less than they pay now for energy and for telecom services and so forth. And this is just one small example of how we can use carbon rewards and how this can also generate significant revenue opportunities for telecom suppliers and carriers. Because now the revenue for the carrier is based on the consumer's energy consumption. So it's a virtuous circle. And so rather than being dependent on triple play and all the complexities and the competitive forces reducing revenue from triple play, a carrier can get revenue from the consumer's energy consumption, and they both win if the consumer reduces their consumption and therefore reduces their footprint. So these are the types of thinking we need, creative thinking, to help address this problem. We don't have to wait for Copenhagen in 2012. We don't have to wait for governments to impose laws. There's significant opportunities now, we think creatively, in helping address this problem. So there's a lot more details on our blogs and websites on this program. There's several initiatives like this in Cleveland, and a couple other places around the world. And I'd like to thank you again for this opportunity to speak here, and I congratulate the organizers for this very important event. Thank you.
Muito obrigado. Dou a palavra ao Carlos do Rinho.
Muito bom dia a todos. Queria começar por agradecer este convite, felicitar a APDC pela oportunidade do tema que foi escolhido para o Congresso deste ano, endereçar uma palavra especial ao Presidente do Congresso, o Engenheiro Jorge Vasconcelos, ao Presidente da APDC, Dr. Diogo Vasconcelos, e ao Presidente da Mesa, Dr. Jorge Moreira da Silva. E queria dizer-vos que eu decidi não fazer um PowerPoint para apoiar a minha apresentação. É um primeiro contributo para a redução das emissões de carbono. Espero, no entanto, que o facto de não usar energia para expor as minhas ideias não reduza a energia com que quero transmiti-las. Nós vivemos hoje um tempo profundamente desafiante. Se escolhêssemos uma palavra para caracterizar o tempo que vivemos, a palavra mais vezes repetida nas últimas semanas, essa palavra é change, mudança. Mas até a mudança já não é aquilo que foi. A mudança já não é aquilo que muda o real. A mudança é o real, ele próprio. E por isso a mudança hoje já não se gera. A mudança ou se antecipa ou se valoriza. E é nessa perspectiva que nós temos que ler todos os números que aqui nos foram trazidos. É nessa perspectiva que nós temos que abordar o desafio da mudança climática. Ela é ao mesmo tempo uma ameaça e uma oportunidade. E, sobretudo, nós temos uma certeza hoje, é que ela faz parte da equação da nova economia que vai renascer da crise. E, portanto, quem melhor perceber e quem melhor integrar a mudança climática nessa equação da nova economia, mais possibilidades terá de se afirmar nesse contexto. As eleições americanas que decorreram recentemente mudaram um pouco a visão e a expectativa que cada um de nós tem sobre o mundo. Introduziram muito o conceito de multipolaridade, sustentabilidade multipolar. Ora, a multipolaridade política é uma impossibilidade se não conseguirmos desenvolver a multipolaridade económica. E a multipolaridade económica é uma impossibilidade se não conseguirmos desenvolver a multipolaridade energética. E é por isso que eu julgo que nós temos que compreender que estamos no limiar do novo salto tecnológico. E que esse salto tecnológico, que sempre aconteceu quando nos aproximávamos de rupturas civilizacionais, se lermos a história, vimos sempre que a ameaça, ou a prática, ou a existência de ruptura civilizacional conduziu a saltos tecnológicos e a novos equilíbrios. Eu acredito que esse salto tecnológico se fará no cruzamento entre a energia e as tecnologias de informação e comunicação, no cruzamento entre a maior eficácia e a maior eficiência. Mas estamos no limiar de um salto tecnológico, estamos simultaneamente no limiar de um salto sociológico. E esta temática das mudanças climáticas é talvez a mais potente temática que podemos utilizar para voltar a recuperar as pessoas para a participação cívica, para o interesse pela causa pública e pela causa privada, pelo interesse geral, pela mobilização participativa. Estamos no limiar de um salto tecnológico, no limiar de um salto sociológico, mas também no limiar de um salto económico. Economia e ambiente, durante muito tempo, foram tese e antítese. Hoje, economia e ambiente fazem parte da síntese da nova equação económica. Isto inclui também e encerra uma forte oportunidade, como aliás se verificaram nas previsões aqui apresentadas anteriormente. Os países mais desenvolvidos serão aqueles que melhor poderão incorporar esta equação e que, portanto, menos impacto terão com as alterações climáticas. E é por isso que vale a pena também completar estas 3 linhas de análise: salto tecnológico, salto sociológico e salto económico, com uma linha de raciocínio que aqui foi muito oportunamente trazida pelo Sr. Presidente da República na sua intervenção de abertura. É que nós estamos também no limiar de um salto em relação às narrativas políticas. E cada vez mais é claro que, na base de todos os modelos sustentáveis, do ponto de vista tecnológico, do ponto de vista sociológico, do ponto de vista económico, está a inclusão digital. A inclusão digital é hoje algo absolutamente crítico para garantir a sustentabilidade e a equidade social. E é talvez essa ausência de inclusão digital que faz com que os modelos matemáticos de previsão, que têm em conta essa não inclusão, nos refletem o aumento das assimetrias de impactos e o aumento das assimetrias de desenvolvimento para os próximos anos, se nada for feito para quebrar esse falhanço básico, esse nó genético básico que é a não inclusão digital, ou se quiserem, a fratura digital. Em torno da inclusão digital e em torno da fratura digital, prevejo eu que, tal como em torno das mudanças climáticas, se vão fazer os verdadeiros debates políticos dos próximos anos. Por outro lado, e é por isso, aliás, deixem-me aqui fazer uma breve nota nacional, é por isso que o plano tecnológico e as políticas públicas em Portugal, de forma tão expressiva e tão exaustiva, procuram contribuir para a redução da inclusão digital. E medidas como o e-escola, o e-escolinha, a ligação de todas as escolas à banda larga, ou tantas outras que nós conhecemos, são medidas claras para criar essa base e esse suporte de sustentabilidade. As alterações climáticas são também parte integrante da visão para o desenvolvimento da Europa nos próximos anos. Nós, na presidência portuguesa, tivemos a oportunidade de desenhar o quadro para o novo ciclo da Estratégia de Lisboa, que depois, em uma articulação muito forte com a presidência eslovena e com a Comissão Europeia, essa estratégia foi aprovada no Comitê de Verão da primavera deste ano, foi lançada, está em plena aplicação, e nesse novo ciclo as alterações climáticas são a linha central, porque são aquilo que permite passar de uma visão baseada na inovação para uma visão baseada na inovação 2.0, ou seja, na ligação da inovação às pessoas, do envolvimento das pessoas na criação do melhor ambiente para os negócios, de mobilidade positiva, de capacidade inovadora, ou seja, das linhas fortes da Estratégia de Lisboa. E eu sei que muitas vezes, quando nós falamos de Estratégia de Lisboa, seja ela vista à escala global, seja ela vista à escala nacional, há sempre quem entenda que essa estratégia é pouco assertiva. A verdade é que a Estratégia de Lisboa foi, nestes últimos 2 anos, a narrativa política vencedora à escala global. A mudança entre a perspectiva quantitativa liberal da economics e o regresso da economia política e das políticas públicas conjugadas em nome de uma visão de desenvolvimento para a sociedade é uma vitória da Estratégia de Lisboa. E a reação europeia à crise, que foi uma reação tardia devido às dificuldades institucionais, foi uma reação inspirada na Estratégia de Lisboa. A Estratégia de Lisboa funcionou sempre como uma espécie de motor de reserva e que nos momentos de crise é acionado. E foi de novo acionado e no final deste mês será em torno da Estratégia de Lisboa que a União Europeia preparará a sua participação na Cimeira Mundial que se realizará em torno da crise financeira. Estes momentos de ruptura são sempre momentos de oportunidade. Portugal foi, também por mérito da APDC, já tive a oportunidade há pouco de saudar o seu presidente, que não estava presente, agora já está, portanto retomo essa saudação. Portugal foi o primeiro país, depois da análise global, a fazer o estudo Smart 2020. Somos os terceiros a incorporar energia renovável no nosso basket energético. Estamos no pódio. E aquilo que muitas vezes acontece no nosso país é que nós, em vez de nos orgulharmos por estarmos no pódio, desconfiamos e quase que nos envergonhamos de estar no pódio. Eu julgo que só quando nós tivermos um orgulho forte naquilo que conseguimos é que isso funcionará como um tónico para o que vamos continuar a conseguir. Nós temos uma visão, que é a visão do plano tecnológico, que é a visão para o país. Nós temos uma visão de aproveitar as vantagens competitivas que Portugal tem por ser um país fortemente relacional, por ser um país em rede, num mundo em rede. E por isso nós queremos fazer de Portugal um living lab global, um país, um passo à frente, um país de experiência disruptiva, um país onde converjam serviços, produtos, pessoas, ideias, que possam ser aqui testadas e vendidas enquanto eficiência coletiva e inteligência coletiva para o mundo. Nós acreditamos, eu acredito, que essa é a nossa grande oportunidade, porque essa é também a nossa grande vantagem competitiva. E no domínio da multipolaridade energética, que terá que suportar a multipolaridade económica, para que seja possível a multipolaridade política, nós temos condições para estar no pódio e temos condições para ser parte da rede de liderança. Eu gostaria de terminar dizendo que, de alguma maneira, sinto que esta conferência e a mostra Portugal Tecnológico, que vai decorrer na próxima semana, também na FIL, embora nas instalações da chamada FIL Nova, são o arranque em Portugal de algo que temos que aproveitar muito em termos europeus, que é o facto de o próximo ano ser o ano europeu da criatividade e inovação. Eu acho que estas duas conferências são o arranque informal do ano europeu da criatividade e inovação em Portugal e na Europa. E eu julgo que é nesse campo da criatividade e da inovação que nós temos uma forte janela de oportunidade que não vamos deixar de aproveitar. Muito obrigado.
Muito obrigado. Tem a palavra o Martin Fleming.
Thank you very much. My congratulations also to APDC for organizing this conference this morning and devoting time to this important topic. As you've been now sitting here for some time, going to offer you a bit of a challenge to get everybody up and engaged here, and that is we need to address an important question. I think we've heard a lot this morning about the changes to the climate that are in the pipeline, if you will, that are about to occur. And the challenge that I offer you is, can we be innovative enough? Is there enough innovation that can occur to help to mitigate and adapt to the impacts of climate change, which certainly now appear to be inevitable? I would assert that there are abundant opportunities for innovation, and in fact, that there are enormous pressures, and those pressures to innovate will only increase. If we think first about the situation that typical businesses find themselves in, you'll see some of the opportunities that we face. We heard from Chris this morning that there are very significant costs to climate change. And I won't take you back through all this again. Some of the work that's been done in the States puts the total cost of climate change over the period ahead at about $20 trillion. Chris's numbers were, his mean number was a little bit lower, but certainly in the same range. The reason why all of this is important is because these costs going forward aren't included within decisions that we take today in the absence of a carbon tax or in the absence of a cap-and-trade mechanism. But as those mechanisms begin to be put into place, private decision-making will be influenced by these impacts. How will private decision-making be influenced? Well, we see 4 different opportunities. First, there are increasing costs. We saw a little bit of that in the presentations earlier with the way in which expenses related to power and transportation and even food begin to increase as climate change begins to be impacted by the decisions that are being taken. Of course, there are regulatory requirements that also have a significant impact, and of course, shareholder pressures that many of us all feel from a wide variety of groups across the business community. And of course, finally, there are new business opportunities. The difficulty we've had in trying to understand these pressures is that we really haven't had any data to understand how they differ. We now have begun to have data become available through work that the Carbon Disclosure Project has been doing, and there are the 1,500 respondents to their survey. And when the Carbon Disclosure Project asks these organizations which of these pressures, which actions they're taking, and what is causing them to take action, here's the picture we see. We've been able to look at data from the U.S. and the U.K. There are other countries represented, but the analytics for this continue to present us with a challenge. But you see that the financial pressures are the greatest cause, are the greatest impact for wanting to drive change. Regulatory pressures are important, but stakeholder pressures are perhaps even more important. Now, what's very interesting here is through the benefit of a different set of policies in the U.S. and the U.K., we've had a bit of a natural experiment conducted. It was nice of the Bush administration to do this for us. And what we're able to learn is that under a different set of policy conditions, we see very different behaviors on the part of businesses. In the UK, where, as you all know, these incentives have been very strongly put in place, we've seen a much stronger response from the business community as a result. Many more actions being taken relative to what we've seen in the U.S. We might expect to see that change, of course, in the years ahead as we now have a new incoming political administration in the U.S. In addition to the incentives to change and the desire and the requirement to change, there's also the question of where can change best occur. Now, here's a profile of energy consumed in the U.S., if we had data from any other country, it would look roughly the same, in that today energy is largely derived from fossil fuel, petroleum, coal, natural gas. France perhaps is an exception because of its significant use of nuclear power. But you see today the alternative energy or the renewable energy sources are still quite small. Another data point of interest is that in the U.S. today, there are about 140,000 megawatts of power in the pipeline coming from wind energy. Now, 140,000 megawatts sounds like a lot of power. But in fact, that's about 1/10 of 1% that's being used in the U.S. today. So if all of the wind power in the pipeline gets into service, it will have a barely noticeable impact on the energy profile in the U.S. So that suggests that at least in the short term, the actions where we need to focus are around the use of fossil fuels. Certainly it's true, as Bill pointed out, that if we see very significant gyrations in the prices of these fuel sources, the incentives, that is the motivation to use these sources more efficiently, will be altered over time. But as we see more steady pressure, the incentive to innovate will continue. And that's a bit of the problem that we've had from a perspective of the price of oil. Back in the 1970s, the average price of a barrel of oil was about $11. In the 1980s and the 1990s, that rose to $25. So it was a doubling of oil prices. But we really didn't see very much impact, either in terms of fossil fuel consumption, slowing the growth of fossil fuel consumption, or the energy consumption profile across different countries. We all know recently we've seen a large spike in the price. Projections now suggest that it might settle down somewhere in the $70 to $75 per barrel range. That would be a tripling of energy prices from the 1980s and the 1990s. It may well induce some change, but that change comes very, very slowly. Again, taking an example from the U.S., given the large increase in energy prices that occurred over the past few years, we've seen barely a noticeable decrease in the amount of driving that occurs in the U.S. So in the short term, these changes are extremely difficult. So where can we look to make change? Well, again, as you heard earlier, the use of energy from the perspective of information technology, information and communications technology, has become very important. It's about 2% of the total. It will likely increase over time, but we shouldn't ignore the fact that there is another 98% or more of energy being consumed in other areas. So we've begun to ask ourselves the question, if we know something about how businesses are responding to financial incentives, which we talked about earlier, if we know something about the profile of energy consumption, what actions can be taken? What innovations can occur in the other 98%? And that's really where we focused a lot of our activity. You've heard mention this morning of the Smart 2020 work and the research that's been done, which has actually been quite important and quite a useful breakthrough in sizing all of this. And you see on the top bar in this chart the 40 gigatons of carbon that are currently emitted on an annual basis, and the ICT footprint, that's a small part of that. The 2002 number represents about 1.5% of the total. On a business-as-usual basis, these emissions would get to about 52 gigatons, and certainly ICT becomes a larger part of the total. If we're to achieve the 2050 targets that have been set, and you saw some of these numbers earlier from Chris and from Bill, that would mean a reduction of about 21 or 22 gigatons of carbon in the next, between now and 2020. Where is that likely to come from? Well, information technology can play a role, and in fact, it's likely, based on the Smart 2020 work, that about a third of that reduction could come from the increased use of information technology. And that's about 5.5 times the direct impact of information technology, which is being offset by a reduction, say, of a relatively small positive, a relatively large negative, about 5.5 times as large. And we'll see those impacts across these 4 areas in the use of power, in buildings, the operation of buildings, in transportation, and in industry. So we'll talk about these each in a bit more detail. The European Union has long recognized the role that information technology can play, and you see some of the actions which have been agreed to. But beyond just the adaptation of current systems with the greater use of information technology, we're also finding that there is a very novel and unique approach being developed in many of the developing countries. For instance, there is a great deal of infrastructure being built in China and in India and in the Middle East. And one doesn't go out and build new infrastructure the way old infrastructure was built. The new infrastructure becomes a lot smarter, a lot greater use of sensors, actuators, controlling devices, etc. One example you might find interesting is that in the United Arab Emirates, Abu Dhabi is now building a city called Masdar. Masdar is a city which will be carbon neutral, and its base of economic activity will focus on clean technology. The challenge in Masdar is to build the carbon neutral city. As far as we know, it's never been done before. And being able to incorporate sufficient technology into the infrastructure, the data center, which there will be only one, by the way, the transportation system, the utility grid, the management of water and waste, all require vast new capabilities which are only now being created. Masdar is viewed as a test bed to take many of these innovative capabilities then and deploy them in other cities in other countries around the world. For example, there are some 200, slightly more than 200 special economic zones being developed in India. Some of them are quite small industrial parks, others are quite large, they're cities, and so as this new technology begins to emerge, it will be incorporated in many of these new cities in various countries. China, Saudi Arabia all have similar projects. So the use of information technology in many of these new cities has become very important. As we think about how to incorporate technology, we've begun to consider the incorporation of the technology across 2 different time horizons. The near-term horizon of anywhere from 3 to 5 to 10 years, and the longer time horizon, 10, 15, 20 years, where in the short term, it's really about efficiency. In the long term, it's really about incorporating renewable energy into the energy mix in a much larger, more significant way. If we were to focus only on renewable energy sources today, we'd be making rather small progress. There's a great deal of progress that can be made in the short term by looking for opportunities to improve energy efficiency while continuing to do the hard work to get into the position over the long term for greater adoption of green technology. From an IBM perspective, this is a very important area of opportunity in business for us. And I just wanted to show you in fact, the depth of the commitment that as an organization that we have, that as you look at our financial roadmap, and there isn't time now to take you all through that, in the center of the chart you see that there is a focus on new growth initiatives, which is a significant part of the expected increase in earnings that we'll have over the course of the next couple of years. And a very significant part is our focus on our energy and climate change initiative. And while we're putting significant increased focus in this area, this is not new for us. The first directive that came to the management of IBM came in 1971 in a note that Tom Watson Jr. at the time, who was the CEO, distributed among his business leaders to focus very intently on the environmental impacts of IBM's activities. And you can see the program began in 1974. There have been an entire series of actions taken over those years. And in fact, now in 2006, have moved yet again to a second generation of carbon reduction goals. Now we're focused on a number of business opportunities. We've talked a fair bit about what we call the energy efficient technology and services, which is around the use of energy in data centers. We've had some discussion around the intelligent utility network, or the smart grid, and we believe that's a very, very significant, in fact, perhaps even one of the most significant. Increasingly, there are opportunities around intelligent transportation systems. You may be familiar with some of that through the congestion pricing and road user charging in Stockholm and central London and other places. But intelligent transportation systems are more than just congestion pricing. It's really about helping to manage and reduce traffic volumes in a systematic way. And as you know, whenever we begin to talk about power, particularly electric power, water becomes an issue as well. In fact, some would assert that the challenges faced from a water perspective are as large, if not larger, than the challenges we face from an energy perspective, and we have a significant initiative around advanced water management. And then finally, carbon management, working with our clients to manage their emission of carbon and working with a number of governments as well, has become very important for us. So finally, just let me share with you some of the partnerships that we have developed over the years and some of the recognition that we've been able to receive as a result. And we continue to see this as a very important piece of our business going forward, because we do believe that the challenges of innovation to respond to this, to both the financial pressures which will be created and the need to address issues around climate change are very important and are a very important part of IBM's future. Thank you.
Muito obrigado. Assistimos a 4 interessantíssimas intervenções, aliás, complementares. Eu penso que nós estamos ligeiramente atrasados. O coffee break devia ter iniciado há 15 minutos atrás, mas penso que ainda poderíamos aceitar uma ou duas questões. Bem, eu faço uma questão. Coloco uma questão ao Chris Hope. A minha questão é a seguinte, e faço uma prévia declaração de interesses, na medida em que estive envolvido, enquanto deputado europeu, nas negociações ao longo do tempo sobre o protocolo de Kyoto, seja na sua fase de desenho, seja na fase de concretização. E considero impossível, apesar da mudança na administração americana, que introduziu uma enorme alteração ao nível da narrativa e, portanto, o diálogo será mais simples, mas considero impossível um acordo imediato, rápido, sobre o pós-2012, se não houver alguma criatividade da parte da União Europeia relativamente a essa negociação. Isto é, olhando para as posições do G77, dos países em vias de desenvolvimento, dos Estados Unidos e da União Europeia, não me parece possível que haja um acordo sem que alguns dos países emergentes, dentro desses países em vias de desenvolvimento, tenham metas sobre as suas emissões. Não falo de redução das emissões, mas de contenção das emissões. Hoje temos 29 bilhões toneladas de CO2 na atmosfera, 6 mil milhões, portanto 6 bilhões correspondem aos Estados Unidos, 5 mil milhões, 5 bilhões, correspondem à China. Em 10 anos, os países em vias de desenvolvimento ultrapassarão os países industrializados. A minha questão é esta. Não considera indispensável que, no regime pós-2012, que aos países em vias de desenvolvimento sejam também atribuídas metas diferenciadas sobre emissões, ou considera que poderemos continuar, como hoje, em que uns têm metas e outros podem receber projetos e emitir créditos, mas só mais tarde serão alvo dessas metas?
Thank you. It's undoubtedly true that we won't solve the climate change problem without the full and active participation of developing countries. China, as you said, is just about to, or maybe has just exceeded the emissions of the US. India, Brazil, Indonesia, all sorts of other countries with very large emissions. However, I don't think there's any way that we can force these countries to become part of a regime that they don't want to become part of. I think that in the medium term, what we have to do is demonstrate to them that we can tackle these problems. We can tackle carbon dioxide emissions. We can tackle other greenhouse gas emissions. And we can do it and grow our economies in a very robust way. And we grow it in a robust way because we get the revenues from taxes or emission permits, and we reduce the cost of employing labour. We reduce any structural unemployment that there might be in our economies, and that has to be a worry now with economies slipping into recession, that we would otherwise have structural unemployment in the developed countries. So we show that we can do this. We show that we will reduce structural unemployment by using the revenues from carbon taxes or from emission permits. And we then look around and see where in the world is the worst structural unemployment. It's not in Europe. It's not in the US. It's in China. It's in India. It's in Brazil. So if these methods to tackle the climate change problem, which allow us to reduce our structural unemployment, work out, and I believe they will, the models say they will, then China and India and Brazil will want to come along. They will want to be part of it because they will see that they can grow their economies more robustly if they tackle the climate change issue as well. So we will have undoubtedly some hard negotiations in Copenhagen and to aim for post-2012 agreements. And I'm sure that those negotiations should continue because that's one strand. But I agree with Bill and I agree with other people here that we shouldn't put all our faith in those international negotiations. We should go ahead and show that we can tackle this problem and grow our economy, and then other countries will want to join in.
Não sei se há alguma... Peço para se apresentar e dirigir a pergunta.
Luís Correia, IST, Technical University of Lisbon. I have a question for our Canadian colleague. You mentioned that the paradox of increasing energy efficient tends to the increasing use of that technology, and then, of course, it may put a problem in it. But isn't it exactly what we want for ICTs, to increase its use for climate change? So if we increase the energy efficiency of ICT as a whole and the technologies that are there, then we can increase the use of ICT and contribute to decrease the 98% there, and on the other hand, decrease the 2% or even keep it stable?
The issue of energy efficiency is it's often used as a surrogate for any other policy to address climate change. And that's what happened back in 1973 in the United States. Rather than putting a tax on gasoline, they just implemented energy efficiency laws, and it backfired on them. And so energy efficiency as a response to a policy of taxes or cap and trade will be a natural response, and it will stimulate further investment in ICT. But to simply think that energy efficiency, a 10% more efficient computer or router is going to help solve the problem, it will backfire on you. In fact, it will increase the demand for more routers and more energy consumption. And there's several studies on this.
Muito obrigado. Penso que podemos aceitar uma última questão, que já estamos mesmo a necessitar de comprar direitos de tempo no mercado. Ao próximo painel. Muito bem. Eu agradeço a presença de todos, em particular dos participantes no painel, e de acordo com o programa, dentro de 7 ou 8 minutos reinicia-se o próximo painel.